Hey guys, this is Miss Garner, and this video will be going over how to solve an equation. So on the very first slide, you will see that there's a review where we are solving for x. There's only one x in your equation. So for this, you're just going to put that wall up at the equal sign and use inverse operations to get x isolated. On slide 2, though, you will see that we have our new content, which is solving equations when there's an x on both sides. So just like last time, you're going to put that wall up at the equal sign. And this time, to make it a little bit more organized, we're going to try to get all of the x's on the left-hand side, and we're going to put all the numbers on the right-hand side. So in order to do this, we're still using those inverse operations. Remember, inverse just means opposite. So I'm going to start by underlining which terms can stay where they're at. So the 9x is already on the left-hand side, so that can stay. The plus 11 is already on the right, so that can also stay. So notice that the 5x and the plus 3 are going to have to switch sides. So to switch those, we'll be using our inverse operations. So for the 5x, it's positive. So the inverse of positive 5x is negative 5x. Remember, if you do it to the right-hand side, you must do it to the left-hand side to keep that equation balanced. So we're going to subtract 5x from the x term on the left. So simplifying here, 5x minus 5x, that is 0, so that just goes away. 9x minus 5x, 9 minus 5 is 4, so you're left with 4x. So your x's have both been combined over on the left-hand side. We're going to do the same thing with our numbers. So remember, we said we needed to move positive 3 to the other side. So the opposite of positive 3 is negative 3. So I'm going to subtract negative 3 from both sides. Once again, remembering that numbers go with numbers, x's go with x's. So positive 3, negative 3, that cancels out to 0. And on the right, we have positive 11 minus 3. That equals 8. So we are back at the point where we know how to solve this equation. 4x equals 8. I'm sure you can do this in your head. 4 times what number is going to give you 8? But to do it mathematically, remember, we're going to use the inverse. So the opposite of multiplication is division. So divide both sides by 4. This is always your last step, is doing this division. On the left-hand side, 4 over 4 can go away. That just equals 1. So we get x by itself. Remember, that is what we wanted. And then on the right, 8 divided by 4 is 2. So your final answer is x equals 2. All right, so it's very similar to what we were just doing. It's just an extra step of having to move multiple things to opposite sides. All right, so slide 3 is one more example. So once again, putting that wall up at the equal sign, underlining the things that are going to stay where they're at. So the 4x is on the left. That is going to stay where it's at. And the plus 16 is on the right. So now we see that our two terms, negative 2 and negative 2x, have to switch sides because we want the x's together on the left, numbers together on the right. So using inverse operations, the inverse of negative 2x is positive 2x. Because I want to keep my equation balanced, I'm going to do the same thing on the left-hand side, so positive 2x. I'm going to go ahead and simplify that. So on the right, they just cancel out to 0. On the left, you have 4 plus 2, so that equals 6x. My x's have been combined together on the left. Now I have to do the same thing with my numbers. So the number that has to move is the negative 2. It's on the wrong side right now, so the inverse of negative 2 is positive 2. Once again, do the same thing on the right-hand side to keep your equation balanced. So negative 2, positive 2, that cancels out to 0. And then your two numbers on the right can combine. 16 plus 2 equals 18. So right now our equation is 6x equals 18. That last step is always going to be dividing by the number in front of your variable. So divide both sides by 6. Notice that on the left-hand side, those go away, leaving you with just an x. Remember, that's what we wanted. We wanted that x isolated. On the right, you have 18 divided by 6, which equals 3. So final answer for that example on slide 3 is x equals 3. You have a couple slides where you have practice problems going over that. But if you go to slide 7, you will see that there's another method for solving this. And I will go ahead and tell you guys that this is usually what students end up using because it keeps your work a little bit more organized. So we just call this the box method, but you're really doing the same thing. All right, so you'll see we have this example here. You have an X on both sides, just like we did, and we're still using the concept that we want all of our X's on the left, and we want all of our numbers to be over on the right. All right, so we're still doing that. So let's go ahead and start by looking at what numbers can stay where they're at. So the 10x is already on the left. That's already on the correct side. So I'm going to go ahead and put that in that first box. Same thing on the right-hand side. That positive 16 is already in the correct spot. So that is also going to just drop down. The other two numbers are going to have to switch over, right? They're crossing that equal sign. So when they cross that equal sign, all you have to remember is that they switch signs. So if it's positive, it becomes negative. If it's negative, it becomes positive. So this 8x, when you put it in the box here, because it crosses the equal sign, it becomes a negative 8x. That positive 2, when it crosses the equal sign, is going to become a negative 2. The reason we do that is because when they cross, we're using inverses, which remember means opposite. That is probably the hardest step for this problem. All we have to do now is add our two small boxes to get the big box. So 10 plus negative 8 gives you 2x. Negative 2 plus 16 gives you 14. Okay, so all we've done is we've added the two little boxes to get that big one. And then just like I said last problem, your last step is always to divide. So I'm going to divide both sides by 2. Notice that that once again leaves me with just an x. So x equals 14 divided by 2, which is 7. All right, so once again, we're still using inverse operations, but the box method makes it a little bit easier to organize. So one more example here. We're going to go ahead and put all of our x's on the left. We're going to put all of our numbers on the right. So the first thing you should do is start with which terms can stay where they're at and just drop straight down. So the negative 5x is already on the correct side, so that gets to drop down. And the positive 12 is already on the correct side, so that also drops down. Your other two terms, though, are crossing the equal sign, so they must switch signs. So the positive 3x crosses over and becomes negative 3x. The negative 4 crosses over and becomes positive 4. You're now going to add the two little boxes to get the big box. So negative 5x plus negative 3x is negative 8x. For your numbers, you have 4 plus 12, which equals 16. And then once again, your last step is always going to be to divide. So divide both sides by the number in front of your x. So in this case, negative 8. When I divide both of those by negative 8, the x is isolated. 16 divided by negative 8 is negative 2. So x equals negative 2. So once again, you've got several more slides going over practice problems. Try to use a little bit of both of those methods. So the first 3 practice problems, use that first way using the inverse operations. The following practice problems, try using the box method.